Hi, in this video we're going to be looking at energy, and we're going to be relating the concept of energy to the process shown here in the picture, where a man moves a distance d, and by so doing raises a block by height h. So, energy. There are two types of energy. Total energy is made up of a kinetic energy, which is based on velocity, plus a potential energy, which is based on position. And we're going to be concentrating on the potential energy in this video and what things control the potential energy. The man is lifting that block, so the block is getting lifted. And if you were to double the distance the block is raised, you would double the potential energy that you're giving it. This is proportional to h. If you were to double the mass and you were to raise it from the earlier to later case, you would double the potential energy change, so it's proportional to mass. And finally, comparing the two cases before and after, if you were to double the gravitational constant, go to a different planet, then it will be proportional to g. So these are three things that we think are make sense that should be proportional to potential energy, and it in fact is correct. EP is equal to mgh. And in particular, the change in EP from the initial case where the object is at the bottom to where the object is on the top, delta EP in this case is mgh itself, because the height is h. Okay, so we're going to use this information now to compare to what's going on with the man. Well, the man is lifting a block, and the block is a free body, so we can draw a free body diagram. The block feels a force mg, and then at the other end it feels the tension of the rope T. And by Newton's third law, if T is the tension that the block feels from the rope from the man, the force the man feels, the tension the man feels from the block on the rope is also T. Good. So we're going to consider the case here, because we're interested in position and not velocity. We're going to consider the case that A, acceleration, is approximately 0. Everything's going to go very, very slowly. So if A is approximately 0, ma is also approximately 0. And by Newton's second law, ma is the sum of the forces, which is T minus mg for the free body. We see then that in the case that acceleration is very small, T equals mg. And now we're going to put all this stuff together and figure out from the man's viewpoint what's happening. And the man is doing work. He's lifting that block. And what are the things that control this work? Well, the more force that he's feeling, the more work it will be. If you double the force he's feeling, you'll double the work he does. So it's proportional to force. If you double the distance you travel, you double the amount of work you do. So it's proportional to distance. And putting those two concepts together, we see that work equals force times distance. And this statement is true when force is constant, as it is in this case. Okay, we can combine everything almost here. Work equals force times distance. The force that the man feels is T, and T equals mg. So in this case, the work is equal to mg. The distance traveled is d, but the distance that traveled d is exactly equal to the height raising the rope. So work equals mgh. And we saw here in this problem, we're considering where velocity is almost zero. There's no acceleration. So for the velocity term, the EK term, we can ignore. Delta ET the change in total energy will have no connection to the kinetic energy because nothing is really moving. It'll be the change in the potential energy. And the change in the potential energy is mgh. And we get to the general result, which is true, that work is equal to the change in the total energy. And we'll be using this result this week.